All right, welcome to Chapter 7 review for Algebra 2. Let's go ahead and get started. Our first few questions here, looking at equations and tables, we need to be able to tell if it shows direct or inverse variation. Well, if we are looking at equations, we always want to look at getting it solved for y first. So to do that on this problem, I'm going to divide both sides by x, and I get y equals 5 divided by x. Anytime that x is in the denominator, that means that it is going to be inverse variation. Okay. And then on the next one, again, we got to get y by itself. So this one, we're going to multiply both sides by y, and I get 15y equals x. And then I need to divide both sides by 15. Y equals x over 15. Well, x is in the numerator, which means if x is in the numerator, that means that it is direct. Okay, moving on to tables. Remember, when we're looking at tables, we're comparing that if x times y is consistent and it is the same every time, then it is going to be inverse. Okay, if y divided by x is the same every time, then it is direct. So let's take a look at what we have. On number 3, if we multiply x times y, we get 32, 32, 32, 32 every time, which means x times y is the same. So this one, excuse me, I almost wrote direct. This one would be inverse. And then on the next one, if you notice, every time we divide, 35 divided by 7 is 5, 55 divided by 11 is 5, 75 divided by 15 is 5. So since they are consistent every single time y divided by x is the same, this one is going to be direct. Okay, looking at the graphs, the first thing we want to look at here is the difference in the two equations that we have. So if you notice, this one has an x in the denominator, this one has an x in the numerator and the denominator, which means how we find the range and the horizontal asymptote is going to be a little bit different for each one of those. What is not different is how you find the vertical asymptote. The vertical asymptote is always when the denominator equals 0. So in this case, x minus 3 equals 0 means our vertical asymptote is at x equals 3. And our domain corresponds to that with all real numbers except for x equals 3. And when we go ahead and draw that vertical asymptote in there, at x equals 3. Okay, and then our horizontal asymptote, when it's written in this form, is basically whatever is added or subtracted to the end. Let's use a different color here. So here, there's nothing actually added or subtracted, which essentially means it's plus 0. So if it had been plus 5, it would have a horizontal asymptote at 5. If it was minus 6, it would have a horizontal asymptote at negative 6. But since there's nothing there in this case, it's plus 0, which means our horizontal asymptote is at y equals 0. So we can go ahead and put our horizontal asymptote in there, and then our range corresponds to that. It's all real numbers except 0. And then when we go to actually graph, since the numerator is positive, it's a positive 4, that means that we are going to be in quadrant 1 and 3. If that numerator right there would have been negative, and this holds true for both types of graphs, if it would have been negative in the numerator, then our graphs would have shifted to here and here. Okay, the second one, if you notice, it has an x in the numerator and the denominator. That means you're just going to have to do a little bit differently. The vertical asymptote is still the same in that it's when our denominator equals 0, so our denominator, x minus 4 equals 0. That means our vertical asymptote is at x equals 4. So we'll go ahead and draw that vertical asymptote in there. Okay. And our domain, again, goes right along with that. It's all real numbers except 4. And then our horizontal asymptote, okay, this is the one that everybody gets confused because when you have an x in the top and an x in the bottom, the horizontal asymptote is the coefficients of x. In this case, the coefficients of x are 3 over 1. So our horizontal asymptote is going to be y equals 3. So if we had y equals 3, here's our graph, and then our numerator, again, is positive, so we can put our branches in here. Okay, so let's pretend for just a second on number 6 that we had 8x plus 3 over 4x minus 2. In this case, our horizontal asymptote would be at y equals 2. Just another example of what you might want to make sure you know. It's not always just going to be the numerator or anything like that. It's going to be the coefficients simplified of x. Okay, so then moving on, we've got multiplying and dividing here. All right, so what I'm going to do first, I'm just going to go ahead and put this all one fraction. And I'm going to make my numerator one simple term here. So I'm going to have 80. And I have an x to the 4th and an x to the 1st. So I'd have x to the 5th times y. And then in my denominator, I have 5x squared y to the 3rd. And then I'm going to look at it and say, all right, I've got coefficients, I've got x's, and I've got y's. And I just need to figure out what that's actually going to be. 80 divided by 5 is 16. X to the 5th divided by x squared. That is subtracting exponents, so we'd be at x to the 3rd. And then y to the 1st divided by y to the 3rd. That y squared is going to be in the denominator. And that's as simple as it gets. Okay, over here, anytime we look at a first step with adding, subtracting, multiplying, dividing, solving, anything, the first thing we do is, can we factor? So we're going to look at each piece and say, can I factor that? Well, x minus 3. Can't really do anything with that because it's already factored. If I have 2x minus 8, there's a greatest common factor I can take out of that with 2, and I would be left with x minus 4. So I'm going to cross that out because I factored it. And then if I go on to up here, 6x squared minus 96, I can take out a 6. And I'm left with x squared minus 16. X squared minus 16 is the difference of two squares, so I would have 6 times x minus 4 and x plus 4. Okay, so I'm going to cross out those because that's how I got it completely factored. And then again, down here on the bottom, I've got x squared minus 9. And that's a difference of two squares, so you're going to have x plus 3 and x minus 3. Cross that out because now we have it all simplified. Now I'm going to look top to bottom and see if there's anything that I can cross out. Okay, well, I've got an x minus 3 here and an x minus 3 here. I've got an x minus 4 and an x minus 4. And be careful because I've got a coefficient here and a coefficient here. 6 divided by 2 is 3. So I'm going to have that reduce. And what I'm left with is 3 times x plus 4 in the numerator and x plus 3 in the denominator. Again, when in doubt, factor, factor, factor. Okay, number 9 is division, so make sure you're paying attention to what signs are in between there. So I'm going to have 5x in the numerator. Okay, I have a greatest common factor in my denominator. I can take out an x. Actually, before I do that, let's erase for a quick second here. And I'm going to take out an x, and I'm left with x squared minus 7x plus 12. I can factor that even further, so I'd have x times x minus 4, x minus 3. Okay, so now that's my denominator. I'm going to kind of cross that stuff out so I'm not getting confused with what I have. And then I'm going to, right now I'm at 5x in the top, x times x minus 4 times x minus 3. Let's go ahead and rewrite that times. Okay, then I need to multiply by the reciprocal, so I'm going to have 15x to the 3rd. And then in the denominator, I can take out a 5x, and I'm left with 4x minus 1. Now I'm just looking at what I can reduce, okay? And let's see, if I look here, I've got an x here and here that I can simplify with. I have a 5 and a 5. I've got an x to the third and an x, which would make that x squared. And then my binomials on the bottom don't have actually anything I can simplify. So I'm left with 15x squared in the top, and x minus 4, x minus 3, and 4x minus 1, all in the denominator. Okay, so we're just going to factor, factor, factor. So I've got x squared minus 13x plus 40. That's going to be x minus 5 and x minus 8 over x minus 5, x plus 3, times, okay, if this is over 1, when we multiply by the reciprocal, the 1 goes in the top, and the x minus 8, x plus 3, once we get that factored, goes in the bottom. And then we just start to look. I've got an x minus 5 and an x minus 5. I have an x minus 8 and an x minus 8. And I'm just left with 1 in the top, and x plus 3, and another x plus 3 in the denominator. And on these, what we probably should have done is to make sure that, other than number 7, is to make sure we list out what our exclusions would be, and we probably should have done that before. But here, okay, so if we look at our denominator when it's factored, we have x minus 4, which means x cannot equal 4. We have x plus 3 and x minus 3, which means x can't be 3 and it can't be negative 3. Number 9, if we look at it in factored form, x cannot equal 0 because of that x right there. It cannot equal 4 and it cannot equal 3. And then here, x cannot equal, what did we have, 5, negative 3, or 8 in factored form. Okay? All right, let's look at adding. Anytime we have to add, we have to find common denominators. We're not solving anything here, we're just adding, like adding things together. Okay, so I have an x plus 3 and I have an x, which means my denominators need to have both of them in there. So I know that my first term has an x plus 3, it's missing an x. My second one has an x and it's missing an x plus 3. So I need to make sure I'm multiplying the top and the bottom by the same thing. And I would have 5x over x times x plus 3 plus, when I FOIL, I would get x squared plus 7x plus 12 over x times x plus 3. So when we combine our like terms, we would get x squared plus 12x plus 12 all over x times x plus 3. And again, that means that x can't equal 0 and it can't equal negative 3. Okay. If we move on to the next one, when in doubt, factor it out. So we're going to factor this one, and it's going to be x plus 8, x minus 3. Okay, so this one has both of them. The first term is missing the x minus 3, so I just need to multiply by x minus 3 on the top and the bottom. And I would get 5x squared minus 15x when I distribute over x minus 3, x plus 8, plus 4x minus 9 over x plus 8, x minus 3. And then when we put them together, we get 5x squared minus 11x minus 9 all over x minus 3, x plus 8. Okay, moving right along here. Factor, factor, factor. First thing I want to do actually before I factor is notice that it's a subtraction in between here. So I'm going to add the opposite to begin with. So I know I'm making sure anything I do, I am distributing a negative 5x. So first thing I'm going to do is I'm going to factor x plus 3, x plus 1 here. And then I've got x minus 3, x plus 3, because these are difference of squares. So I'm going to get rid of that, what I have written there. So I need to have an x plus 3, an x minus 3, and an x plus 1 in both of my denominators. Well, the one on the left, I have an x plus 3 and I have an x plus 1. What I'm missing is an x minus 3. So I need to multiply the top and the bottom by x minus 3. On the right, I have an x minus 3, I have an x plus 3. What I'm missing is an x plus 1. So I need to multiply the top and the bottom by x plus 1. And when I FOIL this up here, I get x squared minus 1x minus 6 all over x minus 3, x plus 3, x plus 1, plus, when I distribute the negative 5x, I get negative 5x squared minus 5x all over x minus 3, x plus 3, x plus 1. Okay, then combine my like terms in the numerator, I end up at negative 4x. Negative 4x squared minus 6x minus 6 all over x minus 3, x plus 3, x plus 1. So our answers aren't always going to be real simple answers here. All right, number 14, when in doubt, factor it out. So let's go ahead and factor. I'm going to have x minus 4x plus 3. This one I'm going to take out a 12 and I'm left with x minus 4. So when I look at what I have here, I have an x minus 4, an x plus 3, and a 12. I already have an x minus 4 over here. So what I am missing on my term on the left, I am missing a 12. So I need to multiply the top and the bottom by 12. And what I am missing on the right is an x plus 3. Okay, so then I would have 12x over 12 times x minus 4, x plus 3, plus 5x plus 15 over 12 times x minus 4, x plus 3. When I put those together, I get, oh, sorry, my numerator up here should be that should be a 12x. I put the wrong thing there. I would get 17x plus 15 over 12 times x minus 4, x plus 3. There we go. All right, last couple of problems here we are actually solving this time. And remember, we talked about how to solve. We said we could either use common denominators to cancel out the fractions, or we could cross multiply. On number 15, easiest route to do here is just going to be to cross multiply. There's one term on each side. So I'm going to go diagonally and I can get 7x equals 5x plus 10. When I subtract 5x from both sides, I get 2x equals 10, and therefore x equals 5. Nice and easy. The second one, again, when in doubt, anytime you're not sure what to do, factor. Again, I've got difference of two squares. So I can rewrite this as x plus 2, x minus 2. If I want to find common denominators to get rid of those fractions, notice on the left I have an x plus 2, x minus 2. On the right I only have an x plus 2, and I'm missing an x minus 2. So then I would have, my denominators would be the same, so I could just say 8x minus 8 equals 4x minus 8. If you subtract 4x from both sides, if you add 8 to both sides, you get that x equals 0. Okay. If you had done cross multiplying, which you also could have done it that way, it gets a little bit trickier, but you would have actually ended up with two answers, and one of the answers would have been extraneous, and the only answer you would actually ended up with is 0. So if you did cross multiply, you would end up at the same answer, but again, you would have had, I think it's either I don't have it written down in front of me, but I think it's either you ended up at 2 or -2 as one of your answers, and that would be an extraneous solution, so it would have not worked, and 0 would have been your only answer. Okay. On number 17, again, factor, factor, factor. I'm going to take out an x, and I'm left with x minus 2. Okay, so I have an x and an x minus 2. So I've got my first term is okay. I need to multiply my second one by x minus 2 on the top and bottom. And then this one I need to multiply the top and the bottom by x. And what I end up with is 10 plus 4x minus 8 equals 5x. And then we're just back to some basic algebra. Let's combine our like terms. 2 plus 4x equals 5x. If we subtract 4x from both sides, we get 2 equals x, or x equals 2. However, don't forget, x can't equal 2 because if you put it back into the original equation, it doesn't make it work, makes your denominator 0, which means that's actually not going to work. So this one has no solution. So just be careful when you're doing these. Always go back and check. Probably should have checked on these other ones too. 5, put that in the denominator, doesn't make it 0. If you put 0 in up here, doesn't make it 0 because you would add 2 to both sides, add 2 to it up here. Okay, number 18. All right, we've got x minus 2 and x plus 2, and then if we factor this, we get x minus 2, x plus 2. Okay, which means we need to multiply this one by x plus 2, this one by x minus 2, and the one on the right's all good. So I end up at 9x plus 18 plus 6x squared minus 12x equals 9x squared. Combining our like terms over here, I get 6x squared minus 3x plus 18 equals 9x squared. It's quadratic, so that's an equal sign. It's quadratic, which means we need to get it equal to 0. And in order to keep that lead coefficient of x squared positive, I am going to subtract everything from the left over. So I'm going to subtract 6x squared. I'm going to add 3x. And I am going to subtract 18. And what I'm left with is 0 equals 3x squared plus 3x minus 18. Okay, next thing, factor. Well, let's take out a greatest common factor to make our numbers smaller. So I take out a 3, and I get 3 times x squared plus x minus 6. If I factor, I get x plus 3, x minus 2, which means the 3 there doesn't count, and we get x equals -3 and x equals 2. We always want to go back, double check, is that going to make my denominator 0? It sure is. It can equal -3, but 2 would make my denominator 0. So in this case, I only have one solution. So my suggestion to you is to make sure whenever you're starting a first step on your test today or tomorrow, make sure you look, can you factor it? Okay, is it factorable like difference of 2 squares? We had a whole bunch of that today. Does it have a greatest common factor that you can take out? Or is it factorable just AC method where you can multiply together to be the number, add together to be the middle term? So good luck, and okay, best of luck.